We are going to review how to solve two-step equations. I'm going to look at 4 different types of two-step equations that you might see. So make sure you take good notes and make sure you're showing all your steps and all your thinking so that you will be able to be successful on all our two-step review. Okay, the first one, this is pretty basic. This is the type of two-step equation that you are most familiar with. 4y minus 4 equals 16. So you'll recall you want to take care of this constant first. Whatever's added or subtracted, you're going to take care of first because we're going in the reverse order of the order of operations in order to solve an equation. So I'm going to add 4, and whatever I do to one side, I have to do to the other. That's the golden rule of equations. So I have 4y equals 20. Then I've got 4 times y, so my inverse operation is division. So I'm going to divide both sides by 4. Whatever you do to one side, you have to do to the other. These 4's cancel, they become 1. So 1y, and I'll just write y, equals 20 divided by 4, which is 5. Okay? Remember, you don't have to every time, but you can check an equation. So we can plug 5 back in for y. We can say 4 times 5 minus 4, and we want to know, does that equal 16? So I get 20 minus 4. That does equal 16, so my answer works. So we don't always show this checking step. You may have been made to show it when you were first learning how to solve equations, but if you're ever unsure, feel free to plug your answer back in and check your work. Okay, the second type of two-step equation, this again is pretty typical, but this one seems to cause more problems for people. I have z divided by 3, so this first term here has division instead of multiplication. Minus 7 equals negative 1. Just like the one that had multiplication at the front, we're going to take care of this minus or addition, whatever is here first. So the inverse to minus 7, the inverse operation is addition. So I'm going to add 7. Whatever I do to one side, I have to do to the other. I'm going to bring down the z over 3. Minus 7 plus 7 is 0, which is what I wanted there, equals negative 1 plus 7 is 6. Okay, now this z over 3, remember a fraction bar is the operation of division. So this is z divided by 3. So if division is the operation I'm seeing here, the inverse operation is multiplication. So I'm going to multiply both sides by 3. This is actually a 3 over 1 here. These 3's, one's in the numerator and one's in the denominator, they cancel. 3 divided by 3 is 1. They become 1. 1z is just 1. It's just z. And 6 times 3 is 18. Okay, just like before, we can check it. I can put in 18 for z. So if I did 18 over 3 minus 7, does that equal negative 1? I would get 6 minus 7, which does in fact equal negative 1. So you can always check your work. We won't do that every time, but don't forget that's a possibility. The next type of problem has a fraction in front of the variable. So we would say this is a fractional coefficient. So 3/7 times x minus 1 equals 8. So just like before, I'm going to take care of this addition or subtraction first. This is minus 1. So my inverse operation, I would add 1 to both sides. I'm going to bring down my 3/7 x. Minus 1 plus 1 is 0. That went away. That's the whole reason I used the inverse operation. And 8 plus 1 is 9. Now, there's a couple of ways to view this and to do this next step, but this is 3/7 times x, right? So my inverse operation is division, so I'm going to divide both sides by 3/7. Okay, so 3/7 over 3/7, that cancels, and I'm left with 1x. Now, this right here, this complex fraction is kind of weird looking, but this is 9 divided by 3/7, right? So you can right now do your fraction operations, keep, change, flip, or you can use your calculator and you can say in your calculator 9 divided by 3, fraction key 7, and you get 21. So either way you want to do it, if you want to do it by hand, if you want to do it in your calculator, I'm fine with that. You could plug that 21 back in and check it if you want. Okay, this last type that we are going to look at. This one is sort of one big fraction. We have p minus 1 all in the numerator. It is sort of in parentheses that aren't written. They're there, but they're just understood. And then it's all over 3 equals negative 4. Well, since the p minus 1 is all in the numerator and in parentheses, we have to get rid of this 3 first. So this is divided by 3. So the first thing I have to do to this one is multiply by 3, multiply both sides by 3. So this one, since it looks different, the reverse solving method is different from what we saw before. Okay, so we're going to take care of this division first. So this is 3 over 3, which is 1, and I'm left with p minus 1. Negative 4 times 3 is negative 12. Now I've got just a one-step equation. I'm going to add 1 to both sides, and I end up with p equals negative 11. So make sure you've got this example written down because some of your practice problems will look like this. It's a little different. Sometimes people forget how to work this one. Okay, so you have an example now of all 4 types of two-step equations that you are going to see. So now you are ready for your practice assignment. You need to get a piece of paper out because you're going to be showing some steps for me, and you are ready to go.